Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 1 over 6 plus n to the power of 1 over 3, and this whole is equals to 1, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first I can rewrite this equation as, here you have n to the power of 1 over 6, and we will write it as n to the power of 1 over 3 times of n to the power of 1 over 2, plus here you have n to the power of 1 over 3, and this whole equation is equals to 1. So after this step I can use here the nice exponential formula, and you know about this formula. If we have a to the power of m to the power of n, so it is equals to a to the power of m times of n. So I can use here this nice exponential formula on the first term, so that here I can write this 1 over 2 in the exponent of n to the power of 1 over 3, so that it will becomes in the form of n to the power of 1 over 3 and its whole power 1 over 2, plus here you have n to the power of 1 over 3, and this whole equation is equals to 1. So in the next step we can simplify this nice algebraic equation, so that here I can put or take y is equals to n to the power of 1 over 3. So when you can put n is equals to 1 over 3 is equals to y, so that this equation will becomes in the form of y to the power of 1 over 2 plus y is equals to 1. So now here we move this y in the right hand side, and you will get here y to the power of 1 over 2 is equals to 1 minus y. So now in order to remove this y to the power of 1 over 2, we will take the square on both of the sides. So when you can take this square on both of the sides, then you see that these 2 and 2 are cancelled by each other, and here you get y is equals to, now we can open the square of this term, and you get here a squared plus b squared minus 2 times of ab. I can use here this nice square identity, and after that we will simplify the terms and we move this y in the right hand side. Then you will get this quadratic equation in the form of y squared minus 2y minus y plus 1 is equals to 0. So now we can simplify the terms, and here you obtain y squared minus 3y plus 1 is equals to 0. So this equation will becomes in quadratic form. So now we can use here the nice quadratic formula in order to solve this problem. So here we have a is equals to 1, b is equals to minus 3, and c is equals to 1. So now we can put these values in quadratic formula, and you know about the quadratic formula. So it will be written in the form of y is equals to minus b plus minus b squared minus 4 times of ac square root over 2 times of a. And now we can put all the values of a, b and c in this formula, and you obtain minus times of minus 3 plus minus minus 3 square minus 4 times of a is 1 and c is 1, and its whole square root over 2 times of a is 1. So now we can simplify the terms, and here you get minus time of minus is plus 3, and plus minus the square of minus 3 is equals to 9, and 4 times of 1 is 4, and its whole square root over 2. So that here we get the value of y is equals to 3 plus minus square root 5 over 2. So here we make the two cases of this equation. So the first case is we take y is equals to 3 plus square root 5 over 2. I can name this as equation number 1, and similarly I can break its negative part, so we write 3 minus square root 5 over 2, and I can name this as equation number 2. So now first I can solve the case number 1. So I can write in the next page here. So here you just write that equation number 1. So here we have equation number 1 is y is equals to 3 plus square root 5 over 2. So I can rewrite here y is equals to 3 plus square root 5 over 2, and now we can back substitute the value of y, and in the start of the problem we will write y is equals to n to the power of 1 over 3. So now we can back substitute the value here, and you get n to the power of 1 over 3 is equals to 3 plus square root 5 over 2. So now in order to remove this power 1 over 3, we will take here the cube on both of the sides, so that when you can take the cube on both of the sides, so these two terms are gone, and here you get n is equals to, now you can take the cube on upper term as well as the lower term, so that here we can first open the cube on the upper term, so that its upper term will be written in the form of a cubed plus b cubed plus 3 times of a into b into a plus b. So I can apply here the nice cubic formula, and whole over you have 2 to the power of 3. So now we will simplify the terms, and you can just get here 3 to the power of 3 is equals to 27, plus here we move this 3 under the square root sign, and you get 5 to the power of 3 and its whole square root, plus here you can multiply the terms. So here you have 3 3s are 9, and when you can multiply this factor on both of these, you will get here 3 3s are 9 and 9 3s are 27 times of a square root 5, and plus you can multiply this pair in this form, so you get 9 times of 5, and this whole is equals to 2 to the power of 3 is equals to 8. And now in the next step we can simplify the terms, and here you obtain 27, and plus here you have 5 to the power of 3 will be equals to 125, and when you can break here 5 times of 2 into 5, so it will becomes 5 times of square root of 5 plus 27 into square root of 5 plus 9 times of 5 will be equals to 45, and this whole over is equals to 8. And now we can add the similar terms. So here you have 27 plus 45 is equals to 72, and plus we can add 27 plus 5 is equals to 32 times of square root of 5 over 8. And when we can separate these terms, then you can get here 8 6 are 48 and 8 9s are 72. So you get here 9 plus minus 8 4s are 32, plus 4 times of a square root of 5. So this is the first root of the given nice equation. So when you can solve, so here I can just solve the equation number 1. So similarly, when you will solve the equation number 2, this equation, then you can get the similar root here, so that I can just write similarly from equation number 2 you will get the other root are n is equals to 9 minus 4 times of square root of 5. So this is the other root of the given equation, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.